Hi, my name is Hamza Shehzad, and I'm going to do the part for the video for my group project that I worked on. So basically, my group, one of my teammates, she already did the gameplay video for that. And if you've seen the video, you've seen that we have 3 levels for each enemies. Let me see if I could run the project. So you can see when you start game, we have all these 10 different enemies. You can see the walking around the map on each different platform because there are 4 below, 1 here, 2 here, 2 there. So this is what I worked on for each level. So there are 10 here, and then there's 10 enemies on second level, and then there's there's more like 9 enemies on the third level, and then each one comes up once you defeat 10 enemies, and then the key pops up. You go to the key, takes you to the next level, and then same thing for the third. But there's one difference in the third level is that I added a troll as a final boss. So I only added 9 enemies in the third level plus one additional troll boss. So these all these enemies that you see in the gameplay, they're all created from these enemies class. I created this enemy class so we could just create an object for the enemy in our main game class here, in the main game class, and we just pass we create the object in the game loop, and then we draw whatever happening. But whatever happening, that's already happened. Those calculations are in the enemy class. And the same thing for the troll class, because the enemy and troll, they both have very similar methods or functions. They both have very similar except for few changes, because since troll is a boss, so I just made a couple of changes for the troll. But similarly, but enemy and troll, they're both very similar. So let me talk about the enemy class, which I worked on. So in on top, all you see here, this one, these are all the variables that I needed for the class for various reasons that they're gonna come up in the methods below that I'm gonna discuss in a few. So these are the ones that I needed. These ones that I created later because I realized that I needed them. But this is what we created. We needed health, attack power is just 10, and this just checks if it's on a platform. Y velocity, just to check for the gravity. We need the velocity. Moving right, just to make sure if it's moving right or moving left, on the platform, we have to check that. And then the enemy has to die, so that's why we need this variable. We need these 2 variables because the enemy is able to attack the player, so we need these 2. Wind up delay, why we need these I actually ended up adding later, because once I first created the enemy class, I did not have these, and I did not have these. So what was initially happening is that as soon as the game starts, the enemy was hitting the player, and the player was dying too quick, and the enemy, it just kept on hitting the player, and then it just without any attack cooldown or the hurt cooldown. So I needed both of these because I want to make sure that the enemy is not just attacking the player all of a sudden as soon as the game starts, and that player just dies quickly. And these I needed. So I was having issue when I was first creating the game. What was happening was that the enemy would die, but then it would get stuck in a enemy in the, what you call it, the dying animation. And then I tried to tweak some things, and then it would just die and then die again. So I had to add this. I was able to find it online. So what basically it does is the dying frame is equal to 0. So the purpose of this variable is that it keeps track of the current frame of the enemy's dying animation. So how it's used is this value, it increases frame by frame to show the correct animation image. So since we have our images here, enemy dying, you see enemy dying underscore rt underscore 1 dot png. So I did it like that. That's why I need the dying frame. And then ready to remove is just once the enemy dies, you just remove them. And dying delay counter, I set it as 5 because this sets the pause or delay between each frame of the dying animation. So I had to set it 5. Why? Because why 5? Because the game is going to wait 5 frames before showing the next dying animation frame. So why I chose that? Because this prevents the dying animation from going too fast. That was another issue I was having. So I just had to create it to 5. It could be 6, 7, it could be any number. You just have to test it, like which one works. So the 5 was good enough, so I just kept it at 5. And then the dying delay counter is the dying delay. I set it at that. because this is just the countdown timer that takes down every game update. That's all this is. And then these are just the poses that I created, RT attack, and these are just the instances of these poses, because when I call these pose, I don't want to pass in current pose as 0 or current pose as 1. It's better to just current pose is attack RT, so we know what's going on. So that takes me to the next method. That's the start attacking. Is these two methods, they're just checking, oh, if you're attacking or not. If is it true? Okay, if you're attacking, what pose are you in? Attack RT or the left RT? And one thing I also want to mention for my project is that this most of the images, the sprites that we found online, like you can see here, most of them, all of them are RT, because when we found these sprites, there were no left. So what I'm doing in this class is that I'm using all the right animation poses, but as you can see in the game, the enemy is able to walk to the right and to the left. So how is it doing it? So I created this flip direction method. It's somewhere here. Yeah, right here. So if it's not moving right, it's moving to the left. So what it does is that it just detects if it's about to fall off the ground, or if there's a solid tile, it just turns around and moves to the left. And I call these methods at the appropriate places. It will come up in the above methods when I'm about to explain those. Okay, so this is the draw method. I will come back to this because first I want to explain the update AI. That's the most important one, because that's the one that we call in our main game. We pass in the enemy object, and then we just call this update AI. And in this method, we pass in player, map, and the tile size, because that is how we are able to update AI. Because without these three, we cannot really do what we need to do in our update AI. So let me explain this method. So first of all, we're checking if the enemy is dying. Skip all logic, no AI needed. It just dies. We just remove it from the map. And if the enemy was recently hurt in a cooldown state, decrement the counter and skip the behavior until recovered. This is where we decrement hurt counter. And then we create the detection range for 400, 300, 400, and detection range for Y as 30. These are just the numbers I picked. You can pick any number you want. You just have to test it, like play around, like what works, what doesn't. And if you're satisfied what you see in the game, and you can just change these values. And then this one, player center X. So what this does is it computes the center of the player, and it computes center of the enemy, but it computes their X positions for player and X positions for enemy, and Y position for player and Y position for enemy. So we know that we can, for the X position, all we need is the width, and in order to get the center, we just need half width plus the player. And then same thing for enemy. And the reason why we call it player.x, player.w here, but not here, because we are actually inside the enemy class, and the class is called this, so we don't need to do this dot. We could have done this dot x plus this dot w, but since we're already in this class, we don't need to do that. But we're not inside the player class, so we need to call the player.x, player.w, so we know which one we're talking about. We're talking about the player. Okay, so next method. So this is just the detection range. This is just math. I pass in those detection range for 4 over here. I just check the range for X and Y. So the player, so what this is saying is that the player must be horizontally within 400 pixels and vertically within 30 pixels to be considered in range. So this just set up the range. And then down below, we just check if not, if in detection range, if the player is in range, that's what it's saying, and can be attacked, no walls in between, same tile row. You see, start wind up when player spotted attack. If not attacking, so we don't just attack right away. So we first we check if it's in detection range and we can attack, then we set up our wind up counter with the wind up delay, because we don't want the enemy to attack too quick. We want a little delay before it starts stacking. Because if you have played video games, you've probably seen like any RPGs you've played and you've come across an enemy, they don't just immediately start attacking you. They wait, and then they attack again, and then there's a cooldown for attack as well, which this is what it does. So there's a delay before it attacks you, and then there's a cooldown after the initial attack. Because this is what I have to add it to go back to add it. I didn't have this when I was first doing it, because and then the enemy would just attack, and then the player would die, and we would just end it at level 1, and it wasn't helping. So I had to go and fix that, and after adding this, it was much better. We were able to complete all 3 levels. Okay. And then this is just else. It's check if it's not attacking, we set up the counter to 0. So reset wind up if player leaves detection. So if player leaves, there's no need to attack. We set the counter back to 0. Keep patrolling the area. Okay. And one more thing for this, so once the delay finishes, let's say wind up counter is equals 0, and attack isn't cooling down, attack counter is equals 0, you begin the attack. That's what it means. And this one is if not attacking, we just check the position. If not moving right, we flip direction. This just check okay. If not attacking, we check for the player center X is greater than enemy center X, and now moving right, we flip direction. Else if player center X. So this, what, like in simpler terms, what it means is that make the enemy turn to face the player before chasing or attacking. So that's what it basically doing. That's why I need flip direction over here, and I need flip direction over here. So this is just checking for left or right position. Else stop attacking. And this over here, this is going to check the if we're on platform. If attacking and on platform, so this is basically the patrol. So they're patrolling, and only patrol if enemy is idle, not attacking, and is on a solid tile, right? So it says if not attacking and on platform. So foot X, what it does, it pixel at the front foot, you know, this right here. Foot Y, it pixel below the enemy, this one. And then this tile front X, this is the tile that the enemy will move into, and the tile below Y, this is a tile under the foot, right? So this just checks that. And then what this does is that if enemy is about to walk off the map of edge, it turns around. So this is just map. So tile below Y greater than equal to map.length, or tile front X is less than 0. So this is just checking that. And so flip direction means, oh, you're walking on a platform, there's a place that you can fall off to, off edge, turn around, return, and just return. So that's why when you check the game, that on a platform enemy was able to walk left and right, and you can see that the enemy at the very bottom, as it was walking, as it gets towards the end to the right, it turns around and it doesn't walk any further. So this one, so this just check if there's a tile below or if there's a tile in the front. And this one, if there's a tile below, tile front, we just pass it in. So first we calculate if there's a tile below or if there's a tile in the front, and then we just create these variables and pass those, because we could have just calculated here, but it's better because we have this tile method. This tile that checks for tile, which is a let me check, I forgot this method we created. You're right here, you see A, B, K for each level. That's why. So in tile it takes characters, so that's why we pass it in. Where did it go? Below tile. And then we check for each character for front X, for tile below, and then yeah, for each front X, and then for the Y position as well. And then yeah, so if it's not a solid tile below or the tile is blocked, we flip the direction. So if there's like a solid tile in the front blocking the view and you can fall off the edge, you cannot walk any further, flip direction, you know, the method we created. So going right, go left, if left, go right. And these Go RT. This is just from our sprite class. Moving right, so this just automatically call those. And you know, in our sprite class, this is extending sprite. Sprite is here. We're using the professor sprite class right here. Go RT, go LT, and this old X, and then move into the new position, keeping account. This is all we did it in class with professors. Moving is equal to true, so I just ended up using that. And then we just decrement the attack cooldown here. So counts down cooldown timer here, and then once it's done, we return the enemy to its walk state. That's all it's doing. And the flip direction I already talked about. This is a moving right. If not moving right, move to the left. If not moving left, move to the right. Okay. So now the next method I want to talk about is if can attack the can attack player, because this is also very important method, because we want to make sure that we're able to attack the player if it's in range. You know, if it's like if it's on the map on the same platform as the enemy. If it's not, then we cannot attack the player. So this one, int enemy feet y and int player feet y, what it does, it calculates which row tile y the enemies and players feet are on, and then ensures both are standing on the same platform row. So if they are standing on the same platform row, that's when the enemy would turn around and detect that there is a player within range, and then it would chase them. As you can see, if you've seen the gameplay, that as soon as we on that, if we are above that tile, it's not going to check us. It's not going to care. But as soon as we're on the same row, on the same platform, it's going to turn around. It's going to, oh, there's a player. Oh, I need to chase that player and I need to hit that player. That's what it does. And this one, if it's not true, we just return false. And this is just the same way that I did before. I was explaining. We just check the center position, because we need for X, all we need is left edge X and half width, and same thing for player. And yeah, that's what it does. And if player, boolean player in front, moving right. So what this does is enemy only attacks if the player is in the direction it's currently facing, right? So if the player is facing away, it's not going to attack. So as you can see, it's only attacks if the player only attacks if it's in the direction it's currently facing. It's going to turn around and attack you. If player not in front, we just return false. And this is just the attack range. I set it up, and then yeah, player not in front. So this I already talked about. So this set the attack range. So what we check, what I mean by attack range is that we know that it's just numbers on screen, right? It's not really real. These are the things that happen, and then we draw them on the screen. So it happens first, and then we just go to the draw method in our main game, and then it draws and shows what has happened. So this is just checking if player is within 100 pixel attack range. That's all this is, 100 pixel attack range. So as soon as you're closer to enemy within that range, it's gonna turn around and chase you, try to attack you. Otherwise, no. And otherwise we just return false, because we're not within the range. Okay. In start X equal to math enemy center. So this is just the check. It's just math. It just checks the range between the enemy and the player. So this is the math. You check the enemy center X divided by tile size, which is 32, player center X. So this just checks that, yeah. And I is equal to start X. So this one, what this does is that it's checking for the walls or tiles if they're blocking your line of sight between player and enemy, right? So that's why we return false. So if there's a line of sight that's being blocked by the enemy and the player, we're gonna return false. But if not, we're gonna return true. If check passes, that means that the enemy is ready to attack, right? It's not being blocked, or by there's a view for the player, for the enemy to attack the player. So return true. Update physics, this is basically just updating the physics. These are self-explanatory. I'll explain this in a few, but let me come back to these. Let me explain the check platform collision, because the collision detection is important. So if we're, and in the collision we're passing in the rectangle class, and that's the same rectangle class that we're using from the professors right here. Why we're using this rectangle class? Because I need this method overlaps. That's the one I'm using, because basically each sprite that you see, if you were to draw in the main game, and each sprite that you see over here is just basically triangles, because when I was building this I tested it out, and then I drew them. All those 10 sprites that you see on the screen in the gameplay, basically they were like rectangles moving. So that's basically what's happening. It's just a bunch of, it's just rectangles. So rectangles, that's why when it collides with the player there's an overlap. That's why we make use of the overlap method. That's right here. If y velocity and overlaps platform, only check the, so what it does, if y velocity is greater than 0 and overlaps platform, this only check the downward collisions. So we want to make sure that we're not falling, like, you know, the player is actually able to stand on a platform, so we don't want to fall. That's why we pass in the platforms. So that's what and then this one right here, enemy bottom y plus h int platform top is equal to platform dot y. If enemy bottom is less than equal to platform top plus y velocity. So this one just ensures the enemy is landing on top of the platform, not hitting it from the side, right? We want to make sure the enemy hits the top of the flat platform, not hitting. That's why we need this y, because, you know, vertical. We're not working with x, we're working with y's. And then this one right here, y is equal to platform dot y minus h, y velocity is equal to 0 on platform is equal to true. So this just snap enemy to the top of the platform, you know, just math. That's what it does. Velocity is equal to 0, right? So snap enemy to the top of the platform, stop falling, mark the enemy standing on solid ground, right? That's what is happening. And this start dying is just basically, this is the method that we call in our main game. So when it starts dying, we call this method. Dying is true, dying frame 0, and current pose dying RT. We pass that because we have the images for this, so we create the animation out of it. But for the left, we just flip the direction. And this one is checking if attack player, if dying return, and then we just player dot take damage, we call the player, and then it's attack damage, attack power, we set it at 10, and then it's able to attack. And then update dying, if dying. So this method that I created specifically for the dying animation, because I was having issues with that, like I explained earlier, that it was dying too quick, or it was just dying twice. So I had to come up with this one. I found this actually online. So what the logic behind this one is, if dying counter minus minus, and if dying delay counter is less than equal to 0, is that every few frames based on delay progress the animation. And then we have a dying frame plus plus, dying delay counter is equal to dying delay. That means that advance to the next frame of the dying animation, right? And if dying frame is greater than equal to 15, ready to remove is equal to true. And once the animation has played all 15 frames, mark the enemy to be removed from the game, which is true right here, right? So yeah, this one just take damage. It allows, this method is simple. We pass in double, it just allows taking damage even if hurting, so death happens right away. So I created this because I wanted to enemy to die right away. I don't want to have any health bar for the enemies. One hit. If you play 2D platformer games, the old school ones, that's how it used to be. Mario 2, one hit the enemy goes. But for boss, I had to not let it die right away. That's why I created a separate troll class, which make use of a lot of these same methods, except for a couple of changes. But most of them are all true, except for like attack power is more, heart cooldown is the same, but attack cooldown is more because it has more, it can attack with more force. So if it was attacking, we won't be able to beat the boss. That's why we need the attack cooldown to be 90, because in our enemy class we have attack cooldown at 60, so we needed more. um what else I didn't explain? Check platform collisions, update physics. This just update the physics for the gravity. And then our draw method right here. So this basically just draws. It draws for dying animation, draws if attacking, it draws for walking, all these animations. And if not moving right, we draw this, else we draw this. What it means, this right here is the image is flipped. So if the image you see on the right, and if you flip it, these are the variables. It's gonna be x plus w, y minus w, and h. And plus y offset, what is that? I set it as 5. This was just to increase the height of the sprite that you see in my game. Because what was happening when I created this, I didn't have this initially, as you can, because that's just a cheap trick I use, because I remember one of my classmates also used it for his player class. He used the y offset as 20 to make the player stand on top of the tile, like it seems that it's walking on the tile. So I ended up setting at 5 because the 20 was it didn't work for me, but 5, as you can see, it looks like it's just a number I came up with. I tried different numbers, it wouldn't work. So when I tried 5, it works. So I just added to h, so it seems like it's standing on top of the tile. And this one, I was just checking. I'm not actually using it, but when I was first drawing the sprites, this is just to check that I can see the rectangles on screen. And when you go to the draw method in the main game, you can test it out. I believe I commented out after I finished making the game, but that's all there is. So this is our enemy class. So before I go to the main class and explain where I call these in the game loop and in our draw methods and in the initialize, let me explain the differences that I have in the troll, because basically the troll is the same as the enemy class. There isn't any much differences. So only difference I would say is that bigger size. The troll is 160 by 160, right? It's not 64 by 64 like our player class. And then we just pass in 10 counts, and the delay is 2, right? And the duration is 2, right? For each frame there's a tick, 2 ticks, right? And another, it has more animations, right? Because for our enemy class we only have RT, attack RT, dying RT. So I didn't want to use troll within my enemy, so I created a separate class, because the rule was for the game development that whatever object we see on the screen, it should be able to draw itself on the screen. So keeping that logic in mind, what I learned in the class, whatever I wanted to place on the screen, I wanted to have its own like class, so it is able to draw itself in the game. So I don't have to do all these calculations in the game. It's being done here, right? That's why most of it I just took it from enemy, placed it in the troll, except for a couple of changes, right? So this one has walk RT, attack RT, we have it in our enemy, but we also have hurt RT, die RT. And this jump RT I added, but I never utilized, like I never made use of it. But I wanted to initially do, because you see in the last level you see 9 enemies and you see 1 troll. So my goal was, what I wanted to do, I wanted to have the AI actually chase the player all over the map. So if the player is jumping, the troll should also jump and follow, and if it's jumping again, it should jump and follow, and then it should follow him all around the map and attack whenever it gets the chance. But I couldn't really, I was having really difficulties. Like I was able to implement it, but then I was having issues with the jump, because it would jump through the tile, and it would sometimes it wouldn't even jump, and sometimes it would get like it was getting complicated. and then if I solve one issue, it would introduce to the next bug. So I just ditched that idea completely, and I ended up going with 9 enemies and just one troll boss. And another idea that I had, we didn't have enough time. What I wanted to do is that on the third level we should just have the 10 sprites, just like level 1, level 2, and then we create another level, and then you create a boss room out of the solid tiles. You just place them on each horizontal of the screen, horizontal side of the screens, and the vertical edges, so it looks like a rectangle closed room. And then there I could have really utilized that boss, that troll boss. I could have added more attack, I could have added power attack, or I could have introduced a rage mode. Rage mode would works like a second phase of the boss. So like in that mode, you're able to throw like fire or shoot something. Like I could have implemented that, but I couldn't think of it wouldn't work with the way the third level is designed with all the platforms. I would have, like, if I were to change this game, that's what I would want to do in the future. Probably make a boss room, and then I could really utilize the troll class there and attack and add more attacks, like, because we're just focusing on boss in that room. We're not focusing on tiles and detection and anything, and just with the player, not with the environment. And another thing that this has is it has more health and more attack power, right? The other enemy only has 10 and health is only 50, but the troll is more. And the logic is the same. It patrols like enemy, uses similar map checks. You see right here, very similar method to AI. All right. And it attacks if player is close, and on same row flips direction before attacks if necessary. So my video is already really long. I don't want to have to explain these because these are the same things. But the only difference is that it shows hurt animation, right? Because our enemy, it just takes the damage. So this is just different from here because our take damage for the enemy, we don't have all these. Where is our take damage, right? We only have the hurt cooldown. If health is less than 0, start dying, die immediately. But for this one, we actually reduce the health from the damage, just like that. But we don't say if health is equal to 0. We pass in hurting is equal to true, because upon getting damaged, you're gonna display the hurt animation. And after all the animation is being, after all the health has been deduced, and then after the hurt animation, you just die, right? And then this is just the update dying, just like that. Over here I'm passing in die.rt, animation die.rt dot image. It's just going to calculate all the images, like how I did it here. I passed in a hard-coded number, but I could have also done the same thing. It's the same, it means the same thing. All right, attack player is ready to remove, flip direction, this is all the same. So most of it is all the same for the player, and for the troll class it isn't much differences. So that being said, so you see we have the check platform collision, same way we have the update physics. We have to pass in the style and then update AI. It make use of the same logic. You see, reuse enemy patrol logic. So whatever I already explained, and this is the draw method is the same way, but the only difference is that the Y offset I added as 25. So this is still the number that I played with. This is not the number that has to be this number. You just have, based on how you created the map or whatever is working for you, just test it. Just like we did it in class when professor was doing the soldier walking through rooms, and it was checking for the X direction for the side wall, like, oh, if it's greater than that or if it's less than that. Same way I did that. You just come check, oh, if 20 not working, how about 21? Oh, 21 not working, how about 22? 22 not working, how about 23? So yeah, so 20, when I put 25 there, it seemed the way that troll was actually walking on the platform. So yeah, so this actually is being used in my main game class, right? So I'm making use of the enemy. Where is our so this was created by my classmate Marcos. This just add enemies to your list, so this wasn't created by me. What I coded for the enemy is in the game loop. initialize and draw. So right here, enemy gravity platform detections and plot. So what we do is just pass in enemies, you know, for enemy, we're just passing the object. We're not actually doing any calculations here. Actually, the calculations, whatever we need to do for the enemy, is being done in our enemy class. So right here, so you see, update physics, pass in gravity. Why we need gravity? So we don't fall off the screen. And then we pass in platform, right? For the rectangle class, why we pass this? To check the collision with the platform, so we stay on the edge. This is being done in enemy that I just explained. Same thing, if enemy on the platform, right? What should be happening when enemy is on the platform? It should be updating the AI. If the enemy is able to detect the player is within range, if it's within range, it's able to attack. And then we added all the hard cooldown, wind up delay, and then update dying. This is the same method. You see, we have it in our enemy class that I explained. We just call it on our enemy. So we just call all these methods. We're not doing any calculations. We just call it in our game loop. And why we do it in our game loop, why we call it in our game loop? Because our game loop runs every 60th of a second, right? So whenever the game comes around, every 60th of a second is going to do this, every 60th of a second. Because we want a video game that's, you know, moving. Is doing that over and over again. We just don't want the enemy to patrol once and then that's it, they froze. Because if we don't put it every 60th of a second, it's going to just, after doing once, it's freeze. That's why we need this. And this is just for the boss. If boss is not equal to null, update y separate from the enemy, because for enemy we're using the iterator, right? And we're using the array list for the enemy. That's why we do it like this. So we put it into each array. But for boss, I created the variable up here somewhere. Yeah, right here, you see, troll boss is equal to null. So that's where I created the boss object. And I since it's only one, I'm not using many bosses, many trolls. So I created a separate object for it, and then I use the same logic up here. I check it up here, update the AI, update the physics, and just pass in those methods into that object. And this is the iterator. This, what basically it does, it safely removes enemy, right? So this is done by Marcos, my teammate. So this is what I'm doing right here. So what this does is checking for the player and enemy interaction, what I could explain in simpler terms. So we check if overlapping and enemies dot attacking, right? So damage and player not attacking and enemy not dying. So all this condition has to be true. First we have to check if the player overlaps and the enemy attacking and the player not attacking, because we cannot do that if the player not attacking, because if player attacking, then we cannot attack. And enemy not dying has to be true, right? So this is just to calculate the cooldown. I added this later on, because like I said, what I have is having issues with the enemy kept on playing hitting the player, and that should have been that shouldn't have been happening. We should have added the cooldown. So there's, and then we added a wind up delay, which I explained, because we don't want to attack as soon as we spot the player initially. We don't want to attack right away. We have to want to wait. And these just sound effects, I didn't add those. And this is where we start the cooldown. That's why we needed the calculate now minus player last hit time here, so we can actually make the now here. So that's actually starts the cooldown. Player dot last hit time is equal to now. And this one I didn't do this. And let enemy handle its own dying updates. So enemy dot update dying. So update dying isn't much right here. Remember what I said about the frames finishing, and then I have to add it up, adding the delay counter, which was up there. I made the variable delay counter, right, to 5, because we don't want to die right away. I was having all these issues, so that basically is just that. And then the iterator, then my classmate created, we just use that to remove all the enemies, right? And then we enemies defeated by level, current level, plus plus. Why we needed that? Because we once we kill the enemies, we want to be able to go to the next level, right? And then we want to remove the enemies per each level, not just in one level. And then this is just same thing as up there for the enemy overlapping the player. This is just the boss overlapping the player, and the same logic for the boss, that for the enemy that I use up here is the same way for the boss, you know. So it just checks if there's a cooldown. It checks it doesn't attack right away after hitting you. There's a cooldown, because if boss attacks you right away again and again and again, there's gonna be a problem. We're gonna die right away. We'll never be able to beat the boss. And then we just update the physics for the boss same way, update the platform, and then update dying. This is just the logic. And then we remove the boss. So we cannot remove the boss using the iter, because there's only one. So we remove it like this. Where did it go? Yeah, if boss are ready to remove, boss is equal to null, enemy is defeated by level, current level, plus plus, but there is no other level to go after defeating the boss. When is defeated by level, current level is equal to 10, game 1 is equal to true. I didn't add these, I believe my classmate did. So this basically, once we defeat the 10 enemies within the third level, is going to show the game 1 is equal to true. That's all this is. And player dot health is less than equal to game over. I didn't add these. So in our draw method, everything from the enemy class has already been happened, and everything has happened in our game loop every 60th of a second. So what do we do in the draw? We just show them, right? For enemies, enemy dot draw. That's what we learned in class. Why we need for loop? Because there's many enemies. If there was only one, all we would need is enemy dot draw, right? Because that's what we learned in the class, that every object that you're gonna have in your game should be able to draw itself on the screen. That's all it's doing. Boss dot draw pen, right? And I did not. Do I have anything else here? So yeah, in my initialize, I need to clear the enemies before, because it's going every 60th of a second. I don't want the enemies to reappear, so I need to adjust enemies positions, right? So in initialize, this is where I placed all these enemies per each level, and then there's only one for the troll, right? Because there's only one troll towards the end. And what this does, this is basically just calculating where to place the enemy on the tile in the screen, right? So screen, I believe in my main applet class, let me go to main applet, I set the dimensions. Oh yeah, right. So 1500 by 18870. So right, width and that height. So keeping that in mind, I had to create this. Where did it go? Yeah, game. So I had to create this, keeping that in mind, that all these values not to go out of the screen. So it only stays within that range, 1500 to 1870. So it just calculates that. For example, 6 is just gonna place that enemy at this position. So S, we know what S is. S is 32. That's the size of the tile. So 6 times 32, that gives us 192, and then that's our X position. And then 5 times S, that's 32. That's 160, right? So this gives us our Y position minus Y minus 64, because that's the height of the player for the offset. So it shows up on the tile. That's why we subtract this offset, because that's what we set the player as, 64 by 64. So we subtract 64, so it lands on the tile, right? And that's what this is. And these numbers are not absolute, like I shouldn't use that word. What I mean by that, this is by trial and error. Like, I could have completely different numbers, and you're gonna see the enemies completely different on the tile, right? On different positions. So I kept playing around with these, I tried different numbers. So when I see that, what I see, whatever you see on the game, all those enemies patrolling, and all this in platform, there's like two of them patrolling, and in some platform there's like three of them patrolling. So that's how I did it. But if I wanted to change it up, all I have to do is just change up these numbers where I want to place them on screen, and it would do that. And that's true for each current level 0, current level 1, current level 2. And I just didn't do these numbers like that. I had to go up here, check at each level map how it was created by one of my classmates, and keep that in mind. I had to really like figure out the positions of where to place them. So that's what I had to do, reading these tiles. So that's why it was important for my teammate to do this tile map first, so I could work on the AI. And once he did that, it became really easy to work on it. So that's our initialize. Anything else? Yeah, so that's all I worked on for my for the group project. I worked on the enemy and the troll, the whatever I explained. So I dealt with the AI. So creating this, what I learned is that it's not as simple. What this taught me, doing this way, the enemy and the troll class, it taught me, compared to other my other programming classes I've taken, that I was dealing with a lot of bugs. It doesn't really happen with other classes like that. What I mean by that is, like, let's say I want to place a, like, you see those AI in the screen. So when I was developing it, I would get introduced to new bugs. So if I'm fixing one bug, I fix that bug, and I'm like, okay, it's fixed, and then that would introduce new bug, and then I fix that, and that would introduce new bug, and then I would find out new bug, new bug. Oh, so it's like you always have to be fixing this. Just so it reminds me of like how games nowadays all have these bugs. So it makes sense. Like, you can't really know if they're there unless you're playing a game and you're checking for that. So handling bugs is one thing that I realize in games. You have to keep it in mind, because I feel like the game that we have right now, we can even polish it further. We can add more things. We can change a couple of things. There might be still bugs in that game that we can fix. So that's what I learned in the group project while doing the AI for the team, and that's it. Thank you.